Hey everyone, my name is Pranav Sharma and today in this video we will be discussing a question that can gravitational acceleration get zero or not. Before discussing this question, we should be aware about a term buoyant force. What is buoyant force? Actually, it is a force which is applied by fluids on an object. In this video, we will not be going in detail of buoyant force. I am just giving you the introduction of buoyant force. What is buoyant force? It is a force applied by fluids on an object. I am standing here. Then basically two forces are acting on me. The first force is gravitational force and second force is buoyant force. Gravitational force is pulling me downward and buoyant force is pushing me upward. We have fluids in our surrounding. What do we consider in fluids? We consider water means liquid or air in fluids. So in my surrounding there is air and the air is pushing me upward. But since the gravitational force is higher than buoyant force, that's why I am standing on the earth. But suppose I have a coke, wooden coke, and I dip it in water. Then after some time it will come upward because the buoyant force by the fluid means water is higher than the gravitational force. That's why it is floating. But suppose if I throw or if I put a pin on the upside of bottle, then it will suddenly sink because it has less area and the buoyant force on that area is not sufficient to compete with gravitational force. That's why it sinks. So buoyant force term is very important while discussing this question. So our question was that can gravitational acceleration get zero? Suppose we have an object. It is falling downwards. Then while falling, two forces are basically applied on this. First is gravitational force and second is buoyant force. And there is fully atmospheric here. So these two forces are competing with each other, and when we are following this, then in starting this gravity will be stronger than the buoyant force. But as we are falling downward, the velocity of this object will increase. And since the velocity of that object is increasing, the air resistance will also increase. Suppose we are driving a bike. Firstly, we were driving it slowly, then we will face slow air resistance, and now we are driving it fast, so we will face higher air resistance, which will let in higher buoyant force. So since acceleration of 9.80 meter per second square is applying on this object, that's why it will have its velocity will be increasing continuously. And since the velocity is increasing, the buoyant force will also be increasing. And then a moment will come in which the buoyant force will get equal to gravitational force, and this will result in the acceleration to get zero. And when the acceleration will get zero, the velocity of this object will get constant, and the velocity at which the acceleration of this object get zero is called the terminal velocity of the object. Terminal velocity. And now its velocity will not increase until it reaches there will be no change in the velocity of this object until it reaches the ground. And this whole concept tells us that gravitational acceleration can get zero. And in definition we can say that what is terminal velocity in gravitational in definition we can say that it is a velocity which a falling object eventually reaches when the buoyant force get equals to the gravitational force. Every object uh, has some terminal velocity. Even human body has a terminal velocity which we reaches when we are doing some skydiving. Then we usually reaches terminal velocity. So this concept or this video tells us that gravitational acceleration can also get zero because of the presence of this buoyant force. Otherwise, in free fall, the gravitational acceleration always works and we always face an acceleration of 9.80 meter per second square. But since we are on Earth and there is atmosphere all around us, then we'll also face buoyant force which will result and which will be an exception of this law of A is equal to always 9.8 meter per second square, and this force will get enough strong to compete with gravitational force, and even it will get equal to the gravitational force and will let the acceleration to get zero, and at that velocity will reach our terminal velocity. And remember that every object has different terminal velocity. It depends upon the area which is in contact with the fluid. Suppose if we are falling a kite from a height, or suppose we are falling a book from a great height, then it will have a different terminal velocity. And suppose if we are throwing this pen from a great height, then it will have a different terminal velocity because the area which will be in contact of the air is different in both the cases. That's why the terminal velocity can get changed. It changes with respect to the surface area in contact with the fluids of the object. So this concept tells us that the gravitational acceleration can get zero, and this video tells us that physics works.